Okay, let's begin with question number 3. Okay, let's move it to a whiteboard, please, and we shall begin. Okay, differentiate this expression with respect to x. Okay, how do we go about that? So the first one, okay, the general formula to use whenever we do polynomial differentiation, differentiation, it looks something like this. So the dy dx, or sometimes people write like ax power of n inside that, and then dx in that, or dy, this is the y inside that. When you differentiate that respect to x, the formula looks like this polynomial. Imagine this has already been established. And therefore, so when we want to differentiate this expression, that means if we let, either we can write like this. It's just a bit complicated to write it like this, but it's not wrong. That's why we just write it as dy dx for short. And it's the same idea because it's distributive. No? It means like you differentiate each term separately and add them up. And before we do that, there's only one step that we need to observe. So I'll just rewrite that step up here so that it becomes more clear, which is it must be written in the exponent form so that it's easier to see. It means the x squared that's in denominator, right, in exponent form is power of -2. And now we would differentiate that with respect to x. So this becomes, according to the an formula, that an x n minus 1. And then this is 6, -2, like that, likewise, -1. Okay. Then we can simplify this further as just 4. 1 minus 1 is x to the power 0 is 0. Aha. X to the power 0. If you want to write it like just for the sake of doing a step, can, even if you didn't write it, it's okay. And then the answer becomes 4 minus 12 over x cubed. Right? Okay, let's do the integration part. Okay, how do we do the integration? So it's a bit tricky. Some of these questions, I mean, it's not difficult, I think, at this point. I mean, usually you may be able to get up to here. But the trick is sometimes when you read it, when you look at it, sometimes you may, because the same expression is used up and down. So the trick is sometimes the mind gets tricked. So some students, they accidentally on the exam day, they're going to integrate the top one or do something like that. It's actually differentiate the top and the bottom, the same expression is integrated. So the formula is in reverse now. That means like if you were to do this, 6 over x squared thingy, dx, we would first want to write it in terms of the exponent form, just like before. So it becomes 6x -2, but dx. And then the formula, it's kind of like in reverse now. So that means if integration of generally just axn dx, I'm not writing the indefinite constant just like that. Write it like better. Put a plus c. Let's do the things to write actually. Okay, so just +1 or n plus 1. I was thinking of skipping some stuff, but then I think better write it in full so it's more clear, something like this. So that's the differentiation. This is the integration formula. So it's just a direct application of that formula at this point, which is, so there's just +1. If you want to indicate the working can, at this level, they don't really bother much about all those nitty-bitty workings like this. You can just skip this and actually just write the next line, but they'll look for a plus C like that. As long as you get the answer correct, usually they'll give you the mark. Okay, so please take note. So 1 plus 1, x squared. This is 2, this is 6, and -1. And this is x to the power of -1, please take note, plus C. So in other words, the answer becomes 2x squared minus 6 over x plus a indefinite, because the indefinite integral, so we put a constant there. Because any constant can be there. In reverse, if you think about it, the constant just represents what is this thing. Differentiated becomes 0, is saying. Okay, so that's the answer. Thank you.